Building on our previous talk about explainable AI, hello, AI enthusiasts. Welcome to a new deep dive. Most videos on machine learning show you the final prediction, but never explain why the model made that choice. In this video, we want to show something different, the circuit breaker test of feature importance, revealing exactly which inputs hold the power over your model's decisions. Imagine our machine learning model is this entire building, and the prediction it makes is the total amount of light produced. Every piece of data we feed it, like the size of a house or its location, is like a dedicated circuit breaker. To understand which feature is most important, we don't need complex equations. We just need to see what happens when a circuit goes dark. Let's test our first circuit, square footage. When we flip this switch off, notice how almost the entire building goes dark. Because removing this information caused a massive blackout in our model's predictive power, we can conclude that square footage is a high importance feature. We record this impact as a tall bar on our importance chart. Now, let's try a different circuit, like the color of the walls. When we flip this switch, only a couple of lights in the storage closet flicker out. The building stays mostly bright. The model doesn't rely much on wall color to make its prediction, resulting in a short bar on our chart. In a real model, we measure this blackout as a drop in accuracy or error rate. We record the model's performance with all features present, then measure how much that performance crashes. The bigger the crash, the more critical that feature was to the model's internal logic. Instead of just turning a switch off, data scientists often use a technique called permutation. Think of it like swapping the wires behind the breaker box so they lead to the wrong rooms. If the model gets confused and the lights start flickering randomly, it proves that feature was vital. Importance can change depending on our perspective. Global importance looks at the whole building to see which switch affects the most lights overall. But local importance looks at a single room, where a specific feature might be the most important circuit. Sometimes, two features are like two switches connected to the same light. If we turn off one but keep the other on, the light stays bright because they provide similar information. This correlation can trick our test into thinking both features are less important than they actually are. Features also interact. Imagine a smart light that only works if both the power is on and the internet is connected. Neither switch is useful alone, but together they are essential. Feature importance helps us identify these synergies between two inputs. The beauty of this circuit breaker test is that it is model agnostic. It doesn't matter if the wiring is a simple regression or a complex neural network. By measuring the output blackout, we can audit any model regardless of its internal complexity. In the real world, this helps doctors see which symptoms are the biggest red flags for a diagnosis. It also helps banks ensure that their loan decisions aren't based on unfair or biased features. By knowing which switches have the most power, we build models that are transparent and trustworthy. Feature importance is your toolkit for looking inside the black box. By treating data like a circuit breaker test, you can identify the drivers of your model's predictions. If you found this visual guide helpful, subscribe for more deep dives into the mechanics of artificial intelligence.